Ooh, negative powers. Welcome back, guys. My name is Miss Danielson, and I'm here to give you another lesson on indices, specifically negative indices or negative powers. I hope you've joined us for our previous lesson on square numbers, cube numbers, and laws of indices, where we looked at the positive powers. If not, I'm linking them down in the description box below, so have a look there if you need to before we get started here. Let's get started. First of all, let's go over the different types of indices that we could have. Positive indices tell us how many times to multiply a base by itself. For example, x to the power of 4 means multiply 4 x's together. X to the power of 3 means multiply 3 x's together. X to the power of 2 means multiply 2 x's together. You see where I'm going with this, but I'm going to keep going. X to the power of 1 means x. And I'm glad I kept going because that's something you need to know. X to the power of 1 means a single x. So if you see an index term with a power of 1, we can simplify by eliminating that 1 and just writing the base. But what if I continued this pattern? X to the power of 4, x to the power of 3, x to the power of 2, x to the power of 1. What if I had x to the power of 0? What would that look like? Well, we could use our division law to continue with this pattern. Let's take one off the indices of all of these index terms that we already know. So for example, x to the power of 4, if I want to do x to the power of 4 minus 1, 4 minus 1, that's 3, and we achieve that by dividing by the base one time. So that's divided by x. Hopefully that's simple and straightforward. Let's just try and continue this pattern. So x to the power of 3 was x times x times x. So if I take 1 away from that index, I make that x to the power of 2. What I'm doing to achieve that is I'm dividing x times x times x by a single x. Let's continue this pattern to see what happens when we get down to x to the power of 0. So x to the power of 2, take away 1 from that index means dividing by the base one time. So my x squared became x times x divided by x, which is simply x. One more time, if I have x to the power of 1, or simply x, and I divide that by x, that'll give me 1. When you divide a value, whatever the value, by itself, you will always get an answer of 1. So the big mistake a lot of people make is when they see x to the power of 0, they assume that means 0, and that is not the case. When they see x with no power, they think that's the same thing as x to the power of 0, which is also not the case. The 0 index means if we had started with a value of 1 and we multiplied by the base 0 times, we would still have just 1. So there's the missing piece to our definition of indices. Indices are not just the number of times you multiply the base by itself. Indices are the number of times you need to multiply 1 by the base value. As you can see, by putting 1 times any of these expressions, I do not change the result. But it does help me to explain why x to the power of 0 is 1 and not 0. You're going to want to write these notes down about positive indices and the 0 index. But let's continue this pattern along into the negative indices. So now I have x to the power of 3, x to the power of 2, x to the power of 1, which I can just write as x to the power of 0. I want to go one more step down to x to the power of negative 1. So rather than subtracting 1 from my indices here, let's try subtracting 2 from these indices, which would mean dividing by x squared. So x to the power of 4 minus 2 would be 1 times 4x's divided by x squared. 4 take away 2 will give me x to the power of 2. Let's continue this pattern to see what we end up with. If I do the same thing to x cubed, I subtract 2 from the index here. That means dividing by x squared. And I've got 1 times 3x's divided by x squared. 3 minus 2 gives me 1, or simply x. And I'll continue down to the next one, x squared. If I take 2 away from the index, That means dividing by the base twice. 1 times x divided by x squared. That would be the same thing as x squared divided by x squared. Any value divided by itself always gives me an answer of 1, not 0. However, using the division law, I'm subtracting my indices. 2 take away 2 is 0. So again, we've proven that a 0 index has a value of 1, regardless of what the base value was. Here's our interesting one. We want to get to negative indices. If I take 2 away from my index of 1, that will give me a negative index of -1. In order to take 2 away from this index, I need to divide by the base twice, or divide by the base squared. So here I've got 1 times x divided by x squared. 1 times x is x over the x squared. Now I can simplify this fraction. Both the top and the bottom can divide by x, leaving 1 on the top, and rather than x squared on the bottom, x to the power of 1, which you see I've done that in pink so you don't need to put it. 1 over x is the same thing as x to the power of -1. Remember, 1 minus 2 is -1. So x to the power of -1 is 1 over x to the power of +1. I'm sure we're going to need another example to explain that, but so far what you should have seen is that negative indices tell us how many times to divide 1 by the base. Rather than multiplying by x, I'm dividing by x. It was to the power of -1, so I'm dividing by x once. Let's try another example, following this pattern again. Rather than taking 2 away from the 4, let's take 3 away from the 4. That means I'm dividing by the base 3 times, right? Well, we can just write that as x. X to the power of 3. If I subtract 3 from this index, that would be dividing by x cubed, and that leaves me with x to the power of 0. 3 minus 3 is 0, and that's x cubed divided by x cubed. This has got a value of 1. Next, I've got x squared. If I take 3 away from this index, that's the same as dividing by x cubed. That would be me doing x squared dividing by x cubed. Simplifying this fraction, I divide both the top and the bottom by a common factor. I can divide them both by x squared, leaving 1 on the top and x to the power of 1 on the bottom, because I've canceled out x squared from the top and x squared from the bottom. That shows me again that x to the power of -1 is the same thing as taking 1 and dividing by x once. So what's this one going to be? If I subtract 3 from the index here, that means dividing by x cubed. That means x is being divided by x cubed, x over x cubed, which can simplify. Highest common factor, I can divide both top and bottom by x. X divided by x is 1. X cubed divided by x will just cancel out one of the x's on the bottom, leaving x squared. So 1 take away 3 is -2, and that's the same thing as dividing 1 by x squared. Right, you're going to need to write these down if you haven't already. The different types of indices that we know. Positive indices tell us how many times to multiply 1 by the base. The 0 index has a value of 1 because we're not multiplying by the base at all. And negative indices tell us how many times to divide 1 by the base. Or more easily, just remember, write a fraction with a 1 on the top and the index term on the bottom, but make that index positive. Now, does that cover all of our different types of indices? We've got positive indices, we've got negative indices, we've got 0 indices. Are there any other types of numbers that we're not considering? These are just the integer values. Remember the positive and negative whole numbers. What about the numbers that fall in between integer values? Our rational numbers or our fractions. That's a different kind of index altogether that we're going to have to look at another time. But definitely make sure you understand these ones. This should be enough to get started, along with the index laws that we know. I hope you've already got these written down as well. The multiplication law, when the bases are the same, we can add the indices. The division law, when the bases are the same, we can subtract the indices. And the power of a power law tells us to just multiply those indices. In this case, we don't need to worry about the bases being the same because we're talking about a single term, a single base, which has got two powers acting on it. Let's try a few examples together to make sure we know how to apply what we've just gone over. So without using a calculator, resolve the following and write your answers either as integers or as fractions. So that means not as a decimal value. For question A, 2 to the power of negative 3, remember a negative index means divide 1 by this value this many times. So I want to divide 1 by 2 repeatedly 3 times. That's going to be 1 over 2 cubed, which I can work out. 2 cubed is 8, so that's 1 over 8. For question B, I need to apply my laws of indices here. These two index terms are being multiplied. The multiplication law tells me to add my indices, so 5 to the power of 5 plus minus 3. And I hope you know your integer calculations. Adding a negative number is the same thing as subtracting. So that's 5 minus 3, which is 2. That's 5 to the power of 2, which is 25. So without a calculator, I was able to work that out. For question C, that looks a little bit more challenging. Darth Vader is there to remind us that we can only use index laws on terms with the same base value. So how could I possibly simplify 49 times 7 to the power of negative 3? Here you need to remember that you know that 49 is the same thing as 7 squared. This is 7 squared times 7 to the power of negative 3. Writing it in this format, you should be able to use your index laws and simplify this easily. 2 plus minus 3 is 2 minus 3. So this is going to be 7 to the power of negative 1. When you've got a negative index, remember we are dividing 1 by that base value one time. So that's 1 over 7. Question D, again, do not have the same base value. Think about how we could get the same base. 8 is the same thing as some value to the power of something. And 4 is the same thing as that same base to the power of something. Have you got it? 8's the same thing as 2 to the power of 3, and 4 is the same thing as 2 squared. So we can write that as 2 to the power of 3 to the power of 4. We're going to have to use our power of a power law there. And we could write 4 to the power of negative 6 as 2 to the power of 2 to the power of negative 6. Power of the power law tells us to multiply our indices together. So 2 to the power of 3 to the power of 4 would be 2 to the power of 3 times 4. And 2 to the power of 2 to the power of negative 6 is 2 to the power of 2 times negative 6. Multiplying out our indices, that's going to be 2 to the power of 12 times 2 to the power of negative 12. Well, that was a nice coincidence. Now our multiplication law tells us to add our indices. So I've got 2 to the power of 12 plus negative 12, which is simply 12 minus 12, which is 2 to the power of 0. Don't stop there. You're not finished simplifying. Remember, any value to the power of 0 has a value of 1. How are we doing so far? If you need help, let me know. Otherwise, let's continue on to some more challenging ones. First of all, without a calculator, this time we are just going to simplify it. We are not going to solve. 5 to the power of negative 3 divided by 5 to the power of negative 2. Using the division law, we are going to subtract our indices. So that's 5 to the power of negative 3 minus minus 2. That double negative, remember, means add. So this is 5 to the power of negative 3 plus 2, which is 5 to the power of negative 1, which we can simplify. A negative index always means divide 1 by this base value, the number of times is indicated. So 1 divided by 5, a single time. I do not need to write that index. For question B, we've got a little bit more of a challenge here because as you can see, our index terms do not all have the same base. Our numerators do, however. 6 to the power of 5 times 6 to the power of negative 3. We could use the multiplication law on those two terms. But the denominator, 36 should be written with the same base as we got above. 36, you should remember, is the same thing as 6 squared. So this is 6 to the power of 5 plus negative 3. And 36 is 6 squared to the power of 2 to the power of another 2. Our power law made us multiply their powers together. So that's going to be 6 to the power of 5 minus 3, because the plus minus means minus, over 6 to the power of 2 times the 4. So that'll be 6 squared over 6 to the power of 8. Now simplifying this fraction, I can divide both top and bottom by 6 squared. So 6 squared divided by 6 squared will give me 1, and 6 to the power of 8 divided by 6 squared will give me 6 to the power of 6. That's 1 over 6 to the power of 6. Now remember, with these examples, we're just asked to simplify. So without a calculator, I'm not expecting you to multiply 6 together 6 times. Next, questions C and D. Again, here's Darth Vader trying to intimidate us with these difficult looking ones. Don't worry, we got this. Just use the force. We got this. Question C, we don't seem to have the same bases for all of these index terms. So let's think carefully. What base could we use that would be the same? 16 is the same as this base to the power of something. 8 is the same as this base to the power of something. 2 is the same as this base to the power of something, and 4 is the same as this base to the power of something. What is the base that we're thinking about? It can't possibly be smaller than 2. 4 is the same thing as 2 squared. 8 is the same thing as 2 to the power of 3, and 16 is the same as 2 to the power of 4. So we can write this as 2 to the power of 4 times 2 to the power of 3 to the power of negative 3 divided by 2 to the power of 5 times 2 to the power of 2, which is our 4, to the power of 3, and all of that to the power of 2. Now that looks really confusing because I'm not sure where the division begins and ends, so I'd much rather write this as a fraction. That way I don't have the bracket confusion. So I've got 2 to the power of 4 times 2 to the power of 3 to the power of negative 3 as the numerator, and that's being divided by 2 to the power of 5 times 2 to the power of 2 to the power of 3, all of that to the power of 2. This is a mouthful, so let's simplify this. Using our power of a power law, we can multiply our indices. So I've got 2 to the power of 4 times 2 to the power of negative 9 as a numerator. And as the denominator, I've got 2 to the power of 5 times 2 to the power of 2 to the power of 3 becomes 2 times 3, 6. Now this is still all raised to the power of 2, so I still needed that bracket down there. Let's continue on over to the right. 2 to the power of 4 times 2 to the power of negative 9. My multiplication law tells me I'm going to add these. So I'm going to do 4 plus negative 9, which is simply 4 minus 9, which is negative 5. In the denominator, I had 2 to the power of 5 times 2 to the power of 6. The multiplication law tells me to add those indices. 5 plus 6 is 11. And I still have to the power of 2 outside that bracket. So just 2 or 3 more steps here. I can next do my power of a power law. 2 to the power of 11 to the power of 2. Multiplying those indices, I'll have 22. So I have 2 to the power of negative 5 over 2 to the power of 22. Finally, this is a division. A fraction is always a numerator divided by a denominator. So this is 2 to the power of negative 5 minus 22, which is 2 to the power of negative 27, which is 1 over 2 to the power of 27. Question D has a star next to it because if you found that previous question difficult, let's really get our thinking caps on here. 18 to the power of 6 times 3 to the power of negative 6. We do not have the same base, and we can't write 18 as 3 to the power of some index. 18, however, can be written as 2 times 9, and 9 could be written as an index term with a base of 3. 9 is the same thing as 3 squared. So that would be 2 times 3 squared to the power of 6 times 3 to the power of negative 6. Now we want to use this power of a power law, but what do we do to the 2? If you think about some bracket which is raised to the power of 6, you have to realize that that whole bracket is being multiplied by itself 6 times. Now, I don't suggest that you expand this out, but I'll show you what it looks like expanded out, just so you can get the idea. So that means that I've got the bracket multiplied by itself 6 times, and within that bracket, I've got a 2. So basically, I'm multiplying 2 by itself 6 times. That would be 2 to the power of 6. And then I've also got the 3 squared multiplied out 6 times. So 3 to the power of 2 to the power of 6, we can use the normal power law as usual. This is going to be 2 to the power of 6, because this is a power of 1 multiplied by 6 gives me a power of 6. And 3 to the power of 2 to the power of 6 will give me 2 times 6, that's 3 to the power of 12, times by 3 to the power of negative 6. Now we've got two terms here which we can use index laws on. The first term has got a different base, so it's just going to stay as 2 to the power of 6. But the last two terms will use the multiplication law, which means add the indices. 12 plus minus 6. That's 12 minus 6, which is 6. So our simplified answer is 2 to the power of 6 times 3 to the power of 6. And we'll just leave it like that. Okay, it's your turn to practice now. Let's first just read these through. So for question 1, A and B, you're just simplifying by using indices. For question 2, you are resolving, that's solving, finding the values of these expressions, but writing your answers in integer or fraction form. So if it's a fraction, don't convert it to a decimal. For question 3, we're using index laws to just simplify these expressions so you don't need to work out their values. Go ahead and hit pause. Take your time to copy the question, work those through, and press play when you're ready to take up your answers. I know these are a bit challenging, so ask me if you need help. Give it a good try. I hope you had a chance to hit pause, because here come your answers. Ooh, how did we do? For question 1, we've got 4 A's multiplied together and 3 B's multiplied together. We can't group those, but we can write them together, A to the power of 4, B to the power of 3. For question B, you should see that there are 4 2's multiplied together and 4 4's multiplied together. Some of you may have left it like this, while others may have taken this a step further, realizing that 4 is the same thing as 2 squared. So that would be 2 to the power of 4 times 2 to the power of 8, which is 2 to the power of 12 altogether. For question 2, leaving our answers as integers or fractions, question A would just be 1 over 7 squared, which is 1 over 49. Question B would be 5 to the power of negative 2, which is 1 over 5 squared, which is 1 over 25. Question C, they don't have the same base to begin with, but think what we did up in B. If you want to hit pause and try it now, please do. Question C is 2 to the power of 7 times 2 squared to the power of negative 3. And then power of a power rule makes that 2 to the power of 7 times 2 to the power of negative 6. And 7 minus 6 is 1. So that just gives us 2 as our final simplified answer. Question D, power of a power law. That's going to be 3 to the power of positive 3, which is 27. Question 3, we don't need to work out the values of these expressions. We just need to simplify them. So don't use your calculator for this. 17 to the power of 2 times 17 to the power of negative 8. Just add your indices. That's 17 to the power of negative 6, which we would express as a fraction. That's 1 over 17 to the power of 6. Question B. Question C. These two index terms don't have the same base, but remember that 4 is the same thing as 2 squared. So simplifying using the power law for the first one, that's 2 to the power of 32. And this is 2 squared to the power of 5, which would be 2 to the power of 10. 2 to the power of 32 plus 10 is 2 to the power of 42. Question D, again, they don't have the same base, but you should know 27 is the same thing as, look at question D above. If you didn't do that, hit pause and try it for yourself. That's 3 cubed to the power of 7 divided by 3 to the power of 6 to the power of 4. That's 3 to the power of 21 over 3 to the power of 24. Dividing both in top and bottom by the highest common factor, which would be 3 to the power of 21, leaves us 3 to the power of 3 on the bottom. We could take that a step further to make that 1 over 27, but as we said, just index laws to simplify. If you've taken it this far, that's okay too. Question E has got a star next to it because it's a challenging one. We cannot get all of these index terms to have the same base. However, we can group our bases of 5 together. 5 to the power of 8 times 5 to the power of -2. We'll do 8 minus 2 is 6. And the 9 is the same thing as 3 squared. So we can do 3 to the power of 5 and 3 to the power of 3 squared to the power of -2. Multiply those indices, that's 3 to the power of -4. And 3 to the power of 5 times 3 to the power of -4. 5 plus -4 is 1. So simplify that, that is just 3. You do not need to put the 1, and if you put the 1, you have not fully simplified. Question F, again, we don't have the same base, but please think, can we get a common base? Your common base should be 2. If you haven't done it yet, hit pause and try that. 4 is the same thing as 2 to the power of 2. 16 is the same thing as 2 to the power of 4. So using my power law, 5 times 3 was 15, divided by 2 to the power of 2 to the power of 8, that's going to be 16. 15 minus 16 is -1, plus the 4 is 3. So our final answer, fully simplified, is 2 to the power of 3. Question G, again, similar to question E, we won't be able to get the same base for all of them, but let's try to get as many common bases as possible. 12 cannot be written as 2 to the power of something, nor can it be written as 3 to the power of something, but we can write it as something times 2 to the power of some value. If you haven't done it already, try and think what we could split 12 into. 3 times 2 squared. 3 times 4 is 12, right? Right, so 3 times 2 squared to the power of 6 divided by 2 to the power of 4. And 9 is the same thing as 3 to the power of 2. So we'll be able to group our bases of 3 and our bases of 2. First, we've got this bracket here, so that 3 is going to have a power of 1 times 6 is 6. That 2 is going to have a power of 12. And my 3 squared to the power of 9 becomes 2 times 9, 3 to the power of 18. Grouping our 3's together, 3 to the power of 6 plus 18, that's 3 to the power of 24. And grouping my 2's together, that's going to be 2 to the power of 12 minus 4. That's 2 to the power of 8. Now, I know that these questions are much more challenging than what you're used to. But if you know me at all, you'll know that I always try to prepare you with the hardest stuff so that no matter what gets thrown at you, you feel ready for it. So how did we do? Did we use index law to take down the negative power? Did we defeat the empire? I hope so. If not, feel free to leave me a comment. And until next time, keep practicing. We'll get it. See you soon.